Hello everybody, this is Shilpa Gogre from Department of Mathematics, Maharishi Dayanand College, Mumbai. This is second part of order properties, which is a topic in the syllabus of first year BSc Mathematics paper 1, the calculus. Now we have already seen some remarks under the heading order properties. Two more remarks will be seen over here. The first one is you have maximum of two real numbers. Let's say the two real numbers are A and B, and the maximum of A and B is defined as A if A is greater than B. So see, maximum is bigger one, you can say, bigger of both A and B. So if A is bigger, who is maximum of A and B? A. And if B is bigger, the answer is B. How do you write it mathematically? The notation used is maximum or max in the curly brackets A comma B. And if you have A greater than B, then the answer is A. And if you have B greater than A, then the answer is B. Now, equality is also possible. You can have the situation that A is equal to B. So this situation or this particular case can be either considered over here in the first, or it can be considered in the second part. It can be considered anywhere. So very obviously, if A and B are equal, what is maximum of A and B? You can write it as A or you can write it as B. It is same. Now the second remark we have. After maximum, obviously the second remark is for minimum of two real numbers A and B. The notation is min. In the curly bracket you have A comma B. Now it is minimum is the smaller of two of them. So if A is smaller than B, the answer for minimum is A. And if B is smaller than A, now B is smaller than A, is also written as A greater than B, as it is written over here. So it means the same thing. So if A is greater than B, that is B is smaller than A, then the answer for minimum is B. Now, before we do the further results, let us recall what we have learned in the first video on order properties. Now R plus, this is the notation which we learned. Just a minute. Yeah. So R plus is the notation. It is denoting the set of positive real numbers, which can also be written as all those real numbers which are greater than 0, strictly greater than 0. And on the number line, see this R, our real number line is seen like this, and you have the additive identity 0 somewhere over here. So all those real numbers which are on the right hand side of this 0, see here, x greater than 0, greater means you are going on the right hand side of 0. All the real numbers which are on the right hand side of 0 are belonging to the set R plus. Now this R plus is closed under addition. That is closureness of R plus under addition, which means by definition, if you have xy belonging to R plus, then x plus y also belongs to R plus. When I say in between the lines, you have to read mathematics in between the lines. What I mean is, this same sentence is read like this. If you add two positive real numbers, R plus means what? Positive real numbers. Then the answer is also a positive real number. This is what is meant by this particular statement, that if x and y belong to R plus, then x plus y also belongs to R plus. Now this closureness of R plus under addition or R plus is closed under addition. This particular property is very, very important, and I will be using it when I prove some elementary results in a short while. Now let us see the closureness for multiplication. So what you have, a very important property of R plus, that it is closed under multiplication, which is also said as closureness of R plus under multiplication. And what is the definition? The definition is like this, that if x and y are belonging to R plus, then xy, what I mean by xy is product of two positive real numbers, that is you are multiplying x and y. So that is what is xy means. Xy also belongs to R plus. So what is it? If xy belongs to R plus, then x into y also belongs to R plus. In other words, you can say product of two positive real numbers is again a positive real number. This is the closureness property of R plus under multiplication. This also will be used for proving some elementary results. So this is also an important property which I am recalling now. The next thing which is recalled over here is the definition of x less than y. This. Now I am taking two real numbers. Please note, I am taking just two real numbers. This is not for R plus. It is for just two real numbers, R. And x is less than y if the difference between y and x, that is y minus x, belongs to R plus. That is y minus x is a positive real number. Now please note that whenever you have a definition, it is actually both way. It is read both way. So if it is given, this part is given, that x is less than y, then what implies is y minus x belongs to R plus. Let me write it. So given x less than y, it will imply that y minus x belongs to R plus. Whereas if you want to prove that x is less than y, we prove y minus x belongs to R plus. Means if y minus x belongs to R plus, it will imply that x is less than y. So that is what I mean by both way. If you are on this side, x less than y, it will imply y minus x belongs to R plus. If you are on this side, that is, if y minus x belonging to R plus is given to you, then you can conclude that x is less than y. Any definition is actually double way arrow. That means start from the left hand side and you can have the right hand side, whereas start from the right hand side of this arrow and you can have the left hand side. Left hand side and right hand side of this arrow, what I mean by that. Let us prove some elementary results now, which are stated under the theorem 1.2.4. The results are for x, y, z, which are real numbers. The first result says if x is less than 0, it implies minus x is greater than 0. So what I mean by x less than 0, that x is a negative real number in our understanding. If x is a negative real number, minus x. Now what is minus x here? What you understand by minus x? It means additive inverse of x. So you know that if x is a negative real number, its additive inverse would be a positive real number. Now we have to prove this. How do I prove it? Now in the first statement, what is given? So I am proving the first statement. What is given is x is less than 0. And what is to be proved? Minus x is greater than 0. So proof is always, as I say, it is a journey starting from the given statement and ending with the TPT statement. So I start with x less than 0. Now what you understand by x less than 0? By the definition we proved here. Let me show it to you. Not proved, by the definition I have recalled here is, see here, if x is less than y, if y minus x belongs to r plus. So I'm using this particular definition over here. This definition I'm using. Okay, so x less than 0, that means, sorry, which implies 0 minus x belongs to r plus. But what is 0 minus x? It is minus x belongs to r plus. And if minus x is belonging to r plus, by the definition of r plus, what we have is that it is a positive real number, that is, it is greater than 0, and that is our TPT. So the proof is over. Okay. The second result over here is x less than y, x less than y and y less than z implies x is less than z. So we all know this property from your school mathematics. Let us prove it using the results which I have recalled now. So what is given here is, I am proving the second property. What is given, there are two given things you can see, x less than y and y less than z. And what is TPT? TPT is which comes after this particular arrow, that is x is less than z. Okay. Now x less than y implies what? By definition of less than, y minus x belongs to r plus. Then you have y less than z, means what? You have z minus y belonging to r plus. Now these are the two statements which I am getting from given. Let us have one focus on x less than z. Let us look at what is to be proved. So to prove x is less than z, actually what I need to prove is z minus x belongs to r plus. If I prove z minus x belongs to r plus, then I have done. I can write x is less than z. So I should get z minus x. Now look at these two statements. Can you get z minus x from these two? How? By adding them. If you add this y minus x and z minus y, what you get is z minus x. Now this is something which is belonging to r plus, y minus x. Another value or another real number which is belonging to r plus is z minus y. Adding them means what? I am going to use the closureness of r plus. So let us proceed. So by closure property of r plus, so by closure property of addition in r plus, let me take the screen up. So I am adding these two real number r plus elements, y minus x and z minus y are added, and they should also belong to r plus. So this is, in the first bracket I am having one element in r plus, and in the second bracket I am having second element in r plus. And because of the closure property, the total or the addition of these two elements in r plus is again belonging to r plus. And by the way, what is the answer over here? See, you can see y and minus y will get cancelled. You can directly write this as z, 1 minute, z minus x belongs to r plus. Now z minus x belongs to r plus means what? You get x is less than z, and that is my TPT. So I've done. Proof is over. We stop here now, and in the next video I will prove some more results under theorem 1.2.4. Thank you.